line, I see three differences with respect to the previous cases. The first one is the peak flow. It's higher. This is fine. The peak flow in the fourth case is just 4 times the peak flow in the first case. This is easy to understand. The base time is longer. This is fine. Okay, because it's time of concentration 4 hours plus rainfall time 4 hours, and therefore I get to a base time of 8 hours. Third difference, you don't have a flat part of the hydrograph. You have just a peak. Good. Now, in these remaining 5 minutes, I want to depict on the blackboard what happens, and it's not depicted here. If rainfall is 5 hours, constant duration, but 1 more hour. Okay. So let me write down this hydrograph. D plus QT. First of all, what is the base time? Or rainfall is 5 hours rain. And let me just I am depicting the yetograph here. It's 4 hours, constant rainfall. So first of all, what is the base time that you are expecting for your hydrograph? I said it's time of concentration 4 hours plus rainfall time 5 hours. So 4 plus 5, 9. So I expect to get to 0 after 9 hours. And I expect, of course, to start from 0 at time 0. And then let me try to, this is 5, 6, 7, 8, 5, 6, 7, 8, and then here I have 1, 2, 3, 4. Good, and let me try to display the grid. Okay. First, for the first 4 hours, nothing changes with respect to the previous case. You see that this is a constant here. If you increase the duration of the rainfall, the first part of the hydrograph doesn't change. Okay, so let me just write down until 5 hours a straight line. Let's see, let's suppose that I get here. So here I have a straight line. Sorry, for the first 4 hours, not the first 5. Okay, here. If you write the summation, you see that for the first 4 hours, it doesn't change anything with respect to this continuous line here. Okay, so what happens after the 4th hour? In this case, you have a decrease. In the previous case, a decrease of the hydrograph. In this case, it is just constant here. It doesn't increase more. Why it doesn't increase more? Because you don't have an increase of the contributing area, of the total contributing area. The whole catchment is already contributing. So if it continues raining, you get just a stabilization of the peak flow. So once that the whole catchment is contributing, if it continues raining with the same intensity, you get the peak flow that is continued. So you don't have an increase of the peak flow anymore. And then after the fifth hour, then you get a linear decrease to 9. So this is what you get. Good. So I'm concluding by getting your attention to an important behavior of this model. Let's suppose that you have constant rainfall, like in this case. The rainfall is constant. What is changing is the duration, okay? So the rainfall value, again, is not changing among these different hydrographs, plus the one that I depicted there. Rainfall is not changing. What is changing, what is making the difference between these cases, among these cases and my case there, what is making the difference is only the duration, okay? So let's suppose that you have this constant rainfall, and you want to study what is the behavior of the hydrograph for increasing duration of the rainfall. So what is an important conclusion that you get? The important conclusion is that your maximum peak flow is reached for duration of the rainfall that is equaling the time of concentration. I repeat, the maximum peak flow is reached for a duration of rainfall that is equaling, that is equal to the time of concentration. Don't forget the hypothesis. Okay, we made a series of them. I remind you the hypothesis. Rectangular shape of the catchment, which means linear. Area curve. Linear area curve. Constant rainfall. These are the two assumptions, okay? You can forget about rectangular shape. Just let's say linear area curve and constant rainfall. So my conclusion of these 3 hours is that if you use this time area method and you have a linear area curve of the catchment and a constant rainfall, you get the maximum flow when the duration of rainfall is equaling the time of concentration. And what is the maximum flow? And then I really finish. What is that? Let me call it QP. It's equal to intensity of rainfall I times A. Total area of the catchment. What is this? It's the CIA formula. It's the rational formula. If you consider my premise that the runoff coefficient is already included here because we are dealing with the net rainfall, then you got back the rational formula. So the conclusion, the overall conclusion is that the time area method and the rational formula, they are strictly related. And you can understand what is the reasoning behind the rational formula. It is the time area method. Good. Not sure if you liked this lecture. I hope so.